Introduction. Your friend challenges you to find if the number 12,345 is divisible by 11 in less than 30 seconds. Is it possible to divide 12,345 by 11 and check? No, that will take longer than 30 seconds. Do you secretly wonder if there is another way to solve the problem? In this lesson, you will learn the divisibility rules and factorization of numbers. Objectives. At the end of this lesson, you'll be able to understand the rules for checking divisibility by 2, 3, 5, 10, and 11. Define prime numbers, define composite numbers, understand prime factorization. Anuj knows that all numbers that end with 2, 4, 6, 8 or 0 are even numbers. He randomly picks up some numbers that end with 2, 4, 6, 8 or 0 and divides them by 2. He observes that each of these leave a remainder of 0 when divided by 2. He then picks up some numbers that do not end with 2, 4, 6, 8 or 0 and divides them by 2. Now he observes that all such numbers leave a remainder other than 0. Therefore, he concludes that a number is divisible by 2 if it has the digit 0, 2, 4, 6 or 8 in its ones place. We cannot apply a similar rule to check whether a number is divisible by 3 or not. You will see why. 33 ends with 3. When divided by 3, it leaves a remainder of 0. Therefore, 363 is divisible by 3. 473 also end with 3, but when divided by 3, it leaves the remainder 2. Therefore, 473 is not divisible by 3. Quite clearly, the rules for checking divisibility by 3 are different. To verify whether a number is divisible by 3, add up the digits of the number. For example, to check if 363 is divisible by 3, we add 3, 6, and 3. We get 12, and 12 is divisible by 3. Add the digits of the number 473. The sum is 14. 14 is not divisible by 3. Therefore, we can say that if the sum of the digits of a number is a multiple of 3, then the number is divisible by 3. Anuj finds it very easy to devise a rule for checking divisibility by 5. Any number that ends with a 0 or a 5 is a multiple of 5. Therefore, it is divisible by 5. Any number that ends with a 0 is a multiple of 10. Therefore, it is divisible by 10. Therefore, any number that contains 0 or 5 in its ones place is divisible by 5. And any number that contains 0 in its ones place is divisible by 10. Consider the numbers 132, 1562, 2717, and 83,919. All these numbers are divisible by 11, as can be checked by direct division method. Consider the sum of the digits of these numbers in the odd places, starting from ones place. Likewise, consider the sum of the remaining digits or the digits in the even places. Compute the difference between the two sums just obtained. The difference is either 0 or a multiple of 11. This is not by chance. It is a general rule. A number is divisible by 11 if the difference between the sums of its digits in the odd and even places is divisible by 11. Look at number 1. It has only one factor, the number 1 itself. 1 is a unique number. Look at the numbers 2, 3, 5, 7, etc. These numbers have exactly two factors, 1 and the number itself. The numbers that have only two factors are called prime numbers. Some other numbers like 4, 6, 8, etc. have more than two factors. Numbers that have more than two factors are called composite numbers. Number 1 is neither prime nor composite. 2 is the smallest prime number. It is also the only even prime number. All other prime numbers are odd. Let us find all the prime numbers from 1 to 100 using a method given by a Greek mathematician called Eratosthenes. List all numbers from 1 to 100. Cross out 1 as it is not a prime number. Encircle 2. Cross out all the multiples of 2 other than 2 itself. Now you will find that the next uncrossed number is 3. Encircle 3 and cross out all the multiples of 3 other than 3 itself. The next uncrossed number is 5. Encircle 5 and cross out all the multiples of 5 other than 5 itself. The next uncrossed number is 7. Encircle 7 and cross out all the multiples of 7 other than 7 itself. All the uncrossed numbers are prime numbers. All the crossed numbers other than 1 are composite numbers. This method of isolating prime numbers is called the sieve of Eratosthenes. When we express a number as a product of its factors, we say that the number has been factorized. Thus, when we write 24 as 3 into 8, we say that the number has been factorized. The factor 8 can be further factorized as 2 into 2 into 2. Thus, 24 can be written as 2 into 2 into 2 into 3. We can also write 24 as 2 into 12. In this case, the factor 12 can be further factorized as 2 into 2 into 3. Thus, 24 can be written as 2 into 2 into 2 into 3. One more way in which 24 can be written is 4 into 6. The factor 4 can be further factorized as 2 into 2. The factor 6 can be further factorized as 2 into 3. 24 can be again written as 2 into 2 into 2 into 3. Thus, in all the factorizations of 24, we ultimately arrive at the factorization 2 into 2 into 2 into 3. In this factorization, the factors involved 2 and 3 are both prime numbers. Such a factorization of a number is called prime factorization. Summary. Let us summarize what we have learnt. A number is divisible by 2 if it has 2, 4, 6, 8 or 0 in its ones place. A number is divisible by 5 if it has 5 or 0 in its ones place. A number is divisible by 10 if it has 0 in its ones place. A number is divisible by 3 if the sum of its digits is divisible by 3. A number is divisible by 11 if the difference between the sums of digits at odd and even places is divisible by 11. Numbers with exactly 2 factors are called prime numbers. Numbers that have more than 2 factors are called composite numbers. 1 is a unique number. It is neither prime nor composite. The number 2 is the smallest prime number. It is the only even prime number. All other prime numbers are odd. Expressing a number in terms of its prime factors is called prime factorization.